Thank you for the opportunity to share some information from Grace today. And really, we want to talk about lockout, tagout, and electrical safety devices, permanent electrical safety devices, and actually how they help us to enhance our programs and deliver a safer, more productive environment for our customers and end users. So that being said, I will move in and talk a little bit about why permanent electrical safety devices. And we'll go into each one of these individually as we go through the presentation. But really, what we're talking about is reducing risk and the number of incidences that are taking place. And we know there's a lot of work going on every single day. And unfortunately, as has been reviewed all morning, we're still exposing people to hazardous levels of energy. We're not keeping our one lines up to date. And even if the incoming power, if the energy provider were to change a transformer outside of your building, you need to compare that to what you had on your original one lines, because that may have changed when they changed that transformer. Most likely it did. So we need to keep all that information up to date, and we need to increase task productivity. And obviously it's very important that we have regulatory compliance. And really we want to make it as easy and as comfortable as possible for our employees to comply and to do their work on a daily basis. Why use permanent electrical safety devices? Really reduce the risk and apply the control measure at the source of the hazard. And really what we're trying to do is to create an environment where we reduce the human error or eliminate it whenever possible. And unfortunately, even today, lockout tagout is one of those areas that still is triggering multiple incidences and causing problems today. And really, we want to make sure that people are properly trained and they are properly outfitted. And really what we're trying to do is to create an environment where they can work at a level where they improve their convenience and productivity and have the proper PPE utilized to do the task. And the outcome from this obviously becomes the reduced lost time, no injuries, no workers' compensation claims, and obviously increased workers' morale. And we say that because our customers who are investing into their equipment and installing these types of device, the workers appreciate that small investment to try to make their daily routine safer and more productive. Speaking of increased productivity, one of the things that can happen if we're able to take a high incident energy task and reduce the amount of time that it takes to put on the PPE, and then also reduce the incident exposure. As we do that, it makes a pretty significant difference in the time it takes to do that task. And it gives us the prioritization of where are our most hazardous locations, how frequently are we doing these lockout tagout procedures, what's our exposure, and then probably the most important is by adding these types of devices, we're able to speed the lockout tagout procedure, which is, some customers have told us they've reduced their task time from as much as 27 minutes down to 5 minutes. So obviously that is a great payback on the productivity. And the main thing is we're continuing to keep people safe in that environment. Some of the earlier presenters today have talked about the regulatory compliance, and just a couple things on that. You know, these products do meet the standards under CFR 1910-147 from OSHA, also the 1910-332 and 333 subpart S. They also help us complying with the NFPA 70E, Article 120, Steps 4 and 7, and we'll talk a little bit more about that. And really, it should take the organizations themselves, make them feel more comfortable in their program, and also give them peace of mind that they are complying and doing what they can to comply with the regulatory compliance. As we look at that, it gives the opportunity to do your work basically for the worker's convenience. At the top order of controls, it gives you the opportunity to very easily pick between your distinction between your qualified workers and non-qualified. I think one of the things that we're all experiencing in industry today is the opportunity to find good qualified workers is very difficult. And there's been a lot of transition over the last couple of years with your example of the entire crew, or the example that came up earlier of the entire crew of the maintenance facility being let go, and an entire new crew in-house. So we need to have a clear distinction between a qualified worker and a non-qualified worker. And from that, we can then define the roles and responsibility, and they are easily assigned, so people know exactly what they can do and what they can't do, and then go into a simplified training requirement, so everybody is up to speed and know exactly what to do. And the outcome is very clear of the roles and responsibilities. We're trying to eliminate or reduce that human error, and depending on the environment and what's happening, there may be a potential to try to reduce some of the required PPE if we substitute that down to the point where that hazard is also reduced. Let's look at some of the basics of safety and why permanent electrical safety devices. As we talked about, one of the things that takes place every single day in a lot of facilities, and I would garner the opportunity to say in most facilities, is they are doing lockout tagout procedures every day, both for mechanical reasons as well as for electrical. Now, Article 120.5 gives us the process for establishing and verifying an electrically safe work condition. What we do is we take devices that reduce that risk, and we present that into that process, and that's done through visual indication as well as voltage portals and also safe test points. And we'll talk a little bit about those different devices, and we'll also talk about some of the facts, myths, and applications as we go through, and then we plan on saving some time at the end for some questions and answers. So real quickly, this has come up frequently, and really the three most important elements of an electrical safety discussion are really the hazard, the risk, and then the control. And I know the majority of people on this call today have seen the risk control hierarchy before and are familiar with it, that the best activities take place at the elimination of risk. If we can create an environment where we are able to eliminate the risk, and we reduce the amount of incident energy that's available, or eliminate the exposure, that's obviously a best practice and is the most effective. If there's a way where we can substitute that risk, can we change the current system? Can we go to a faster fuse? One of the things that we can do to try to substitute that risk and reduce it, and then incorporate engineering controls accordingly. In the earlier presentation where they talked about the distance from the disconnect to the actual point of work and how that changed that transition. So maybe we put in a secondary disconnect closer to that final point of work, if that's possible, as another way to engineer around it. And the key factor too, as you talked about, is the awareness, making sure that people know exactly what their hazard levels are aware of the work to be done, have prepared for the work, and have the appropriate tools and the information available. and then administrative control, and then basically the last line of defense is really the personal protective equipment. And do they have the right equipment on? Are they prepared to do the task? Is the equipment operating in normal operating conditions? So again, the hazards are anticipated, identified, and evaluated. The risk is derived from those identified hazards and are assessed and prioritized. And then the controls are applied to reduce the opportunity to the lowest potential. So let's talk real quickly about a mechanical versus electrical lockout tagout. And here you see on your screen on the left-hand side, we have the energy isolating device, or the disconnect, or however you want to phrase it. Then you actually have the motor that it's connected to, as well as the pump that the motor is connected to. So let's say, for example, this motor is operating fine, but we do realize that one or two of the bolts at the foot of that motor have actually come loose. So we need to work on that piece of equipment. The best practice to do that would be obviously to isolate the motor from the source. So we're going to go ahead and disconnect it, throw the energy isolating device, throw the disconnect, and then make sure there is no stored energy anywhere, and then go ahead and make that adjustment at the motor and tighten it back up. And the delineation here between a mechanical lockout tagout and an electrical is we're not going to open up the motor cover. We're not going to engage with the wiring. We're not going to touch anything. We're simply there to tighten up a mechanical connection basically at the base of the motor, and then continue the work. So if we're going to actually touch conductors or rewire, then it becomes an electrical lockout tagout. If we're just doing something on the mechanical side, obviously it's going to stay as mechanical lockout tagout. And then of course out to the pump, if you wanted to modify something out of the pump, you could do that, again verifying that there is no stored energy, and in that case it may be gravitational or pressure, so the pump could start to rotate. How do we achieve a zero energy state? And there's different ways to go about it, and it depends on the lockout type. So today we'll talk real quickly about a mechanical lockout like we just did. Then we'll go into a low voltage and then also a high voltage. Most facilities are operating in the mechanical and the low voltage. Some are also in that high voltage, but really come up, you're going to open the energy isolating device. You're going to affix your locks. You're going to try to actuate the device. After the locks have been applied, you're going to try to start the device, and none of those things take place. And then you're going to return and make sure that the device is in the quote off position, and then you're going to go to work. From there, now we're going to touch conductors, open the cabinet where the drive is for the motor, whatever that might be. You're going to open the energy isolating device, affix the locks, try to actuate again, hit the start button, return to device position, make sure and verify that it's in the off position. And then you're going to take out your meter and perform a 3-point test using your test meter, and you're going to test it to a known source. You're going to test both phase to phase and phase to ground. And at this point, we're assuming that you have got all your PPE on, you've prepared for the job, and you know exactly what tasks need to take place. And then at that point, you're going to verify that your meter is still working, and then you're going to go ahead and start your work. Moving into high voltage, very similar to low, with the addition of get a visual open in the circuit. So look for visible blades, verify that they have opened up, and then again, you're going to apply your locks and tags, try to start the device, return the device to the off position, and then perform your 3-point test using voltage testing devices. And you're going to phase to phase and phase to ground test, and make sure that everybody around the work and starts work installs their personal protective grounds. That being said, Article 120 of NFPA 70E helps us in creating the environment for and a process for establishing a electrically safe work condition. And the first thing that you're going to want to do is to determine all possible sources of the electrical supply to the specific equipment. You're going to check the applicable update to drawings, diagrams, and identification tags. Now, this is critically important to make sure that you know where it's being supplied from and make sure that your drawings and information is up to date. And that's where, companies like Easy Power and others can be very helpful to make sure that you're up to date. After properly interrupting the load current, open the disconnecting device for each source, and wherever possible, you're going to visually verify that all the blades have disconnected and are fully open, or that the draw out type circuit breakers are withdrawn to test the fully disconnected position. You're also going to want to release any stored energy. That could be, for example, a feed into a variable frequency drive that has capacitors, which will have some stored energy. You're going to wait till that bleeds down. Then you're going to block or relieve any stored non-electrical energy, like we talked about with the pump or something along those devices. Make sure that they cannot be unintentionally energized, and then apply the lockout tagout devices in accordance with a documented and established procedure. And you really want to make sure that everybody is up to date with the equipment, has gone through and understands each of the job tasks that are appropriate. And at the very end, you're going to use an adequately rated portable test instrument to test each phase conductor or circuit part, both phase to phase and phase to ground. And before and after each test, determine that the test instrument is operating satisfactorily through the verification process. So you're going to start at a known source, check your meter, verify it's working, do the measurements, verify that there is no energy, and then go back and recheck your meter. So live, dead live on the test equipment. Article 120.5 under NFPA 70E has made some changes in the last several years. And this, as we just discussed, is the process for establishing and verifying the electrically safe work condition. And in this case, they've added an exception, and that is exception number 1: an adequately rated, permanently mounted test device shall be permitted to be used to verify the absence of voltage of the conductors or circuit parts at the work location, provided it meets all the following requirements. It is permanently mounted and installed in accordance with the manufacturer's instructions. It tests conductors and circuit parts at the point of work. It is listed and labeled for the purpose of verifying absence of voltage. It tests each phase conductor or circuit part, both phase to phase and phase to ground, and the device is verified as operating satisfactorily on any known voltage source before and after verifying the absence of voltage. And what this has done, and this exception really talks about the process of doing that lockout tagout procedures, and it ends up basically you have UL 61010-1, which talks about the safety requirements for electrical equipment measurement, control, and laboratory use. General requirements for the rating over voltage category, and then the design requirements for voltage measurement and test instruments intended for use on electrical systems 1,000 volts and below. So what they do is they take a look, UL tests the equipment, verifies that it operates properly and that it passes their requirements for that level. Informational note 2 talks about UL 1436, which is for outlet circuit testers and other similar indicating devices. And the reason that these other products were slotted into this category is they didn't necessarily match everything under a UL 61010 environment. But they did match the requirements under the outlet circuit testers and other similar indicating devices. And it's actually added further technology into the lockout tagout procedure. and creates an opportunity to continue to evolve how that lockout tagout procedure takes place. And really what it does is creates an environment where you have to make sure that when you're doing your lockout tagout procedures that you have a qualified person. I do appreciate the way that this is shared from the standard. And basically, a qualified person is one who has demonstrated skills and the knowledge related to the construction operation of electrical equipment installations and has received safety training to identify the hazards and reduce the associated risk. Here's the part I really like: an unqualified person, a person who's not a qualified person. So there are requirements to be a qualified person. It's stated very clean and simple, and really understanding the type of task, who's performing the task is extremely critical, and then verifying, is this a mechanical lockout tagout or electrical? So understanding the difference. So a voltage presence test for a task qualified person, also considered an unqualified person. There are devices out there that are created to give you the opportunity to see that the voltage is present, and that's going to give you a visual indication of some type. And then when you go into your electrical lockout tagout, there are devices that are giving you the opportunity to use your meter and do your live dead live test to prove out the voltage absence. And also you've got a combination package of products that give you the visual presence and absence accordingly. And we'll talk about these a little bit now. And real quickly, I want to talk about the voltage indicators themselves. They have basically one task, and that is to show you the presence of voltage. And it's used in a couple of different ways. One is to show that everything is operating correctly. In the example here in the upper left-hand corner, we have the voltage indicator showing L1, L2, and L3. It is visually flashing at those, and each one of these is doing a similar thing. What this is doing is showing that there is voltage present on those three phases. There is no voltage showing on the ground, and that's all this device does, is it measures phase to phase and phase to ground all the time. And it just gives you an opportunity to do some troubleshooting and take a look at your equipment and see what may be happening inside that equipment. So voltage indicators are meant for presence of voltage indication only. Obviously, pilot lights are not to be used for any type of absence of voltage testing at all. And they're just as they are, just a pilot light. It just says there's energy there. So let's break that down a little bit further. In where would a permanent electrical safety device be mounted? And in this circumstance, we've got a fuse disconnect. We've got your A, B, and C phase, as well as the ground. And a couple different features available are really flashing and non-flashing. Most customers prefer the flashing because it attracts a little bit more attention. But one unique thing about this is it's fed from the line voltage. And that voltage can be anywhere between 30 volts all the way up to 1,000 volts DC or 40 volts to 750 volts AC. And this device is simply comparing phase to phase and phase to ground. So it gives you that opportunity to see the visual, and then it also will verify that those three locations are actually, the voltage levels are similar. And if that disparity between A to B or B to C gets to around 11%, it's going to start to flash on the ground. So a lot of customers like this when they have to do some troubleshooting as a problem occurs. But if we were to blow that fuse and we just dropped L1 out of the circuit, you'll see that that voltage, as we measure phase to phase and phase to ground, is now starting to flash on the ground. So it's letting you know that there has been a loss of power on L1, and you can start to use this for some troubleshooting. If we were to open up L2, now you'll see you're in a single phase environment. A couple things could cause the single phase environment. It could have been you had just thrown the disconnect, and 2 of those 3 blades released. Another potential problem is thunderstorm comes rolling through and the energy provider has lost a couple of legs on their system and they're providing a single phase. And really this gives you the visual opportunity to determine what is your procedure from here in this abnormal condition. And you can react accordingly. So going back again, typical environment, 480, you're going to have three lights flashing and seeing that the energy's there. These are high surge immunity. They're Cat 3 and Cat 4 rated. They are a fully potted construction. There's a lot of different various mounting options. It typically takes about 20 minutes to install these types of devices, and they are UL listed 261010 as we had talked about. We realize that not all the equipment gets mounted onto a MCC or an industrial control cabinet. There are a lot of individual panels on various production environments and on the shop floor. And we've got a couple different opportunities there to put at these smaller disconnects, just a simple power yes, power no, give you the visual indication, and at those small disconnects. So whether it be a small rotary type or the lever type, could be on lighting panels, all sorts of different things. These are also available in a 4-wire or a 5-wire. And again, the Cat 3 and Cat 4 and UL listed to 61010, type 4, 4X, 12, 13, all the way up to an IP67 rating. So offer some flexibility there to get out on the plant floor where you're seeing more and more of the mechanical lockout tag out and some enhanced electrical, and the opportunity to verify quickly and easily that the system has cleared. And on these, for example, it could be on a long conveyor system or something like that. There is a mechanical jam on the equipment, so you're starting to get a buildup of boxes or something like that. You could simply walk up, see the disconnect, throw the disconnect, watch the stored energy go away, then go out, because now there is no energy flowing, and you're going to remove that stuck box and then come back after you've cleared that, go ahead and throw the disconnect and then bring that particular system or conveyor up and running. So it's very quick, very efficient, and becoming very popular. An additional aid for mechanical lockout tagout is basically a pass-through voltage portal. This is really designed to utilize the opportunity of a non-contact voltage detector. Several different manufacturers. This particular one is manufactured by Fluke. They'll basically measure voltages from 90 volts all the way up to, I don't know, 230, 240, somewhere in that range. And it just gives you the opportunity to say, is there voltage there, yes or no? This gives you that opportunity because we create an environment where you can measure it at the point of use and just verify, again, for a task qualified person, not an electrically qualified person. For the electrically qualified person, we take the hazard of doing the lockout tagout, we bring it to the outside of the cabinet, and we take that measurement at a test point that's actually mounted on the cabinet. And it doesn't matter the frequency that it's being provided, whether it's 50 hertz, 60 hertz, or all the way up to 400 hertz. This is being utilized on the output side of some variable frequency drives, and still gives you the opportunity to measure that the voltage is no longer present. We have a high impedance circuit built in, and what we do, as you already know, is the impedance basically reduces the amount of current available. And when we have an opportunity to take a voltage measurement, you'll see in the cartoon there on the left-hand side, you're actually inside the cabinet at the point of the feed, and you're exposed to the full hazard and the full energy. In the case on the right, you're going right up to the safe test point. You're going to insert your probes. You're going to take the voltage measurement there. And we have that high impedance circuit, so we reduce the available current to less than or 4 milliamps or less. We know that that level is beneath the OSHA shock hazard, and we're taking something that is exposing the individual from a high incident energy to a low incident energy. And we do that in an environment where it's controlled and much cleaner and much safer. These devices are tested to UL 61010, which we had talked about before. That is the standard for testing most of the equipment in the industrial world from an electrical perspective. And the test reports accordingly, and it's pretty straightforward. This is in the handouts that you'll receive, so it's quickly and easily available for your reference. Here's an example of a customer who took the opportunity to create a situation where they are using a visual indicator at the top above the disconnect. And that's really reminding people that the incoming energy is still there in the cabinet. And then you've got your disconnect. Below the disconnect, you've got another voltage indicator, again, voltage presence. And then beneath that, you have the safe test point. So now if you were going to lock out at this particular cabinet, you could come up to the equipment, see that the line side is flashing, the load side is also flashing. Take your meter, go to a known source, verify your meter, open the cover of the safe test point, measure that there's voltage there, throw the disconnect, watch the stored energy go away on the load side, and then insert your meter probes and verify that from the bottom of the disconnect down, that equipment is isolated, and any stored energy downstream, like at that variable frequency drive or other locations, anything with capacitors, those have now cleared, and then you can continue your work, put the lock on and continue your work. Realizing that the top voltage indicator there is going to continue to flash to tell you that the line side feed is still hot. So you don't want to be interfacing up there or doing any work in that area. A new product that's been added, we've had a lot of customers requesting this. It's basically to go all the way up to 1,000 volts on both the AC and on the DC. It's used in varying worlds, but as we go to more and more high voltage DC applications and high voltage AC applications, we're getting more and more requests for this type of product in the automotive world and the solar world and others. And really what we've done is we've added 164 k ohm impedance. In this case, it affects the typical multimeter, which is basically a 10 mega ohm is the most common. It gives you a variance of about 3%. And really what we're looking for is not voltage quality, it's voltage yes, voltage no. We're in the lockout tagout procedure, so we're just trying to find out, do we have energy, yes and or no. Pretty straightforward. That product is becoming very popular because of that. Really what this does, the visual indicator as well as the safe test point, gives you the opportunity to do this lockout tagout procedure outside the cabinet in a controlled environment. We're using an adequately rated test instrument. We are testing face to face and face to ground like the code is requested. We're also testing the instrument to any known source before and after the test. Really the key takeaway is the VTS helps you meet step 4 and step 7 is outlined in Article 120.5 for the process and procedure of your lockout tagout. These products are becoming very popular because of the fact that they isolate the individual from the high incident energy and give them the opportunity to do that testing from outside the cabinet. A couple other key factors. There's no need for the battery or a battery in this. You actually have 2 independent devices that are connected to the same source, redundancy, that are telling you in a visual format that there is no energy there, as well as the safe test point, which is giving you the opportunity to do your metered and measured test. So it's very straightforward, very simple. There are no fault codes. It's either voltage yes or voltage no. And if there is voltage on your meter, you can see the level of that and the available. Basically, we get the opportunity to retrain how people are going to do this, use their existing process for a lockout tagout procedure, but we're going to create an environment where it is not exposing them to that hazardous energy. So when you talk about approaching the cabinet, you're going to verify, is it in normal operating conditions? Then you're going to verify, is there voltage here, yes or no? And then you go through your procedure. We don't want to reinvent the wheel or have to retrain. What we have done is taken the risk control hierarchy, taken the best practices of elimination of risk or substitution of risk through engineering controls, and created an environment where they can do that lockout tagout procedure in a safe environment without exposure. Taking a look at OSHA in 1910, 333, a qualified person shall use the test equipment to test the circuit elements and electrical parts. They shall verify that the circuit elements and equipment parts are de-energized. And if the circuit to be tested is over 600 volts nominal, the test equipment shall be checked for proper operation immediately after the test. So you're going to test your meter, do your process, verify your meter. Going back to Article 130.2, defines the operating conditions. So when should this or when can this be used? Again, as was mentioned in the previous presentation, as well as I'm sure other things earlier this morning, the equipment is properly installed, the equipment is properly maintained, the equipment is used in accordance with the instructions included in the listing and labeling of the manufacturer's instructions. The doors are closed and secured. All the equipment covers are in place and secured, and there is no evidence of impending failure. The key takeaway here is performing absence of voltage test using your voltmeter from outside the door is considered normal operation following the facility's PPE requirements. And this is really gaining in popularity because it is very efficient and is such a valuable tool as far as reducing exposure and risk hazard. So that's why it's really becoming quite popular. There's a little bit of conversation taking place. There is, we talked earlier about the new exception number 1, which allows the user to opt for a permanently mounted absence of voltage tester. And that is permitted to be used to test for the absence of voltage. Conductors or at the circuit parts at the work location. The key points is, as the title says, this is the exception. This is an exception. User facilities may choose to use this exception instead of following step 7 under Article 120. However, the exception only applies to step 7. So the other steps involved in Article 120 are still required. And the device has to be UL listed and labeled to UL 1436. The GRACE permanent electrical safety devices do not meet the exception, and they don't have to, because they basically meet the rule in the UL 61010 category rating. And the key factor for the safe test points is with that device installed, one can easily follow step 7 in a much safer and more convenient way. Real quick, just know that these devices are going to be used throughout your facility. It could be at a individual tool like a drill press, at 120 volts or 208 volts. Could go into your distribution panels. It could go to your variable frequency drives, your motor feeds, fan feeds, and also all the way up into your incoming utility equipment onto some of the MCCs and other locations. And the device is intended for use with measurement all the way up to Cat 3 1000 volt rating and Cat 4 at 600 volts. The key takeaway here is ensure that your product is suitable for the application and the environment, and go ahead and quickly install it according to the manufacturer's installation instructions, and then utilize the best practices in Article 110 for reducing the hierarchy, reducing risk. So again, we focus on those top three areas, which are eliminating, substituting, and engineering controls around those hazardous areas. And then we want to make sure that we're keeping people aware of what's going on, administrative controls, and making sure that they are dressing appropriately for the occasions. If we go back to the earlier arc flash presentations that were shown, you saw how big a difference it is when they're properly dressed and protected with the appropriate amount of PPE. Probably the biggest feature that employees and employers like utilizing these types of products is really the productivity improvement. We touched on this a little bit earlier, but from a productivity perspective, customers are increasing productivity as much as 74%. And for mechanical lockout tagout, it's about 66%. So they are saving a lot of time in their processes and changing their procedures. And really, we want to change the way people act around live voltage. And with that, I'll open it up. Randy, if there's any questions, and appreciate the opportunity to be with the entire group today and share some of this information.
Machine safety lockout. There's a lot of interest in that. I've had a lot of comments from companies about how different they are, whether or not those two different things, how they work together. Machine lockout tagout and electrical lockout tagout.
Okay, so a lot of the machine lockout tagout has to do with installing guards to keep people away as the machine is operating. So the machine won't operate if those guards are not in place. And that is one way to do it. And then, of course, depending on the type of equipment, you're still going to have hazards there, but really it is these mechanical guards that are keeping you away. Others have a light sensing relay, if you will, that if you break that plane as you're reaching into the equipment, it's going to go ahead and trigger a stop, which is going to stop all the mechanical movement, and depending on the design can go ahead and trigger an electrical lockout, which it just releases the energy and it can't move.
Yeah, does a company need to have both standards? Are they part of the same lockout program?
Not typically. So you're going to have a mechanical lockout,
right,
for those reasons. Yep. Yeah. And then electrical lockout when you're going to be touching conductors and rewiring equipment, that type of thing.
Okay. When it comes to electrical safety programs, I asked this earlier to Jim about arc flash studies. Is it better to hire a consultant to do an electrical safety program development for a company, or have it done internally?
That's kind of a catch-22. If you have the appropriate people on staff with the talent and the knowledge and the ability to go ahead and create those programs, it is good to do that. And I know a lot of companies who do have, quote, a homegrown electrical safety program. But we're seeing more and more of those qualified individuals, quite honestly, retiring. And you had mentioned earlier on the airport example, a lot of the qualified known people who knew the systems retired or were let go.
Yeah.
And it's time to. The available technology out there, calculating the arc flash studies and so forth, has gotten to the point where using companies like Easy Power is a very quick, efficient way to go and utilize the software available. Or again, go to the third party and have them come in, do the assessment, do the walkthrough, analyze all your current practices, and then give you the best approach to move forward.
You know, a few years ago, we delivered electrical arc flash training for Canada Post here in Vancouver, and Canada Post had 40 electricians working in their facilities in the Vancouver area. they had Canada Post had developed for all their facilities across Canada, they had developed an arc flash electrical safety program with, you know, documentation and everything. And they had done that internally and created posters and everything. When our instructor went to teach according to that program that they had developed, it was discovered that the program was developed based on a standard that was 8 years old.
Yeah, and it, you know, as we
So
talk,
so it didn't have up-to-date information from the actual standard. So that's because they did that internally.
yes, yep. Where if you have someone coming in and they can evaluate, so what equipment has changed, what transformers have changed, what switchgear has been changed, all of those different things come into that calculation.
Right. And what kind of buy-in is it needed from management? Is this really from bottom up or is it top down? The electrical safety program development, adherence, documentation, all of that. What drives that?
You know, in our circumstance, the groups that we're working with, it's more bottom up because they are the ones that are doing the actual work. They would like to see the elimination of the risk or the substitution accordingly. And, you know, these are relatively easy to install devices. They're very inexpensive when you compare to the cost of PPE and some other things. And they just make sense. So once that process starts, typically with the operations group, the production group, or the maintenance group, corporate management is usually quick to join in the process because of the opportunity for the increased productivity, as well as the cost savings, and really the increase in safety.
And it's all related to finance, correct?
Yes. Yep.
Yeah, always. Is that still the main driver behind all of this?
Unfortunately, yes. As you know, with safety programs and so forth, that we've always done it this way, it should be fine.
Yeah, I mentioned earlier, I don't know if I mentioned earlier, when we started way back when NFPA 70E developed, or NFPA developed the 70E, and then before this was even CSA Z462, we produced a course for one of the utilities in Canada, and we had 40 people there, 20 people from management, 20 people from the unions. After 2 hours, the union people stood up and walked out. They said, we've heard enough. This is not a work practice issue. This is an engineering issue. And if the equipment is too hazardous to work on, that we have to wear beekeeper outfits and put on gloves and go into confined spaces with face shields that we can't see the color of the wiring, we're going to cause accidents. So we'd rather work de-energized.
Correct. Yeah. And whenever possible, that is by far the best practice.
Right. And this created a big conflict in the company because it wasn't properly dealt with. They just thought this is a PPE issue.
No,
right.
As you know, there are a lot of different circumstances where you can't dress for the occasion. You are working on a bomb. The question is, how big's the explosion?
That's right. Yeah. And there's such a large expense in redesigning electrical systems that many companies thought, well, we'll just solve the problem with PPE.
Correct. Yeah. And, you know, let's face it, Randy, to dive into that just a little bit, when it's my hands going in the cabinet, it becomes very personal. When it's somebody else's hands going in, it's a task, right?
Yeah, that's so correct.
The thing that they can both agree to is, let's not put our hands in the cabinet while it's still live. Let's do it after the fact. Nope. Thank you. Appreciate the opportunity.
Okay.